we will see conditional probability. That is, what is the probability of B when A has already occurred? Then what is the relation between A and B? So we'll start with event. We had defined event in our first class only. So any subset of the sample space is called event in terms of set theory. Mathematically, we are talking of mathematical definition. So any subset of the sample space is called an event, and an event is of two types. Either it is simple event or it is compound event. Simple events are those events for which the set has only one element, single element. For example, if the sample space for throwing a die is 1, 2, 3, 4, 5, 6, a subset which represents a simple event can be an element 6 only or 5 only. But compound events are those events for which we have more than one element in the subset. For example, when we throw a die, then the event of having an even number is a compound event, because 2, 4, 6, there are 3 elements in the subset which correspond to that event. So that is compound event. Now compound events are of two types: independent events and dependent events. Those events which are not related to each other, which are not dependent on each other. For example, throwing a die and throwing another die. These two events are not related to each other. So they are called independent events. Till now we have dealt independent events only. Now we will deal with dependent events. Events which are dependent on some other event. So let's see, let's define it and let's solve the problems. Now we define conditional probability. Conditional probability of B when A has already occurred. This is B by A denotes conditional probability of probability B when A has already occurred. This is conditional probability. Again I am saying, this PB by A, it represents conditional probability of B when A has already occurred. What is the meaning of this? Let's see. Let's say we throw a die. The sample space will be 1, 2, 3, 4, 5, 6. Then let's say A is the event of getting an even number. A is the event of getting an even number. So what are the sets? What are the elements of this set? 2, 4 and 6. These are even numbers. And let's say B is the probability of getting a 6. So this will be 6. Okay. In this case, A intersection B, this works as the event. What is the event? Event is probability of getting a 6 when an even number has been obtained while throwing a die. Okay? So A intersection B is the event now, and this A works as sample space. Sample space. So how we take out the probability? Probability becomes number of elements in A intersection B by number of elements in A. Okay? We have all these figures. Let's see what are there. Number A intersection B is only 1, 6, only one element, and NA is 3. So the probability that a 6 is obtained when an even number is obtained while throwing a die is 1 by 3. This is called conditional probability. But before proceeding further, I request you all to subscribe this channel and also share this channel, share this video with your friends and colleagues and ask them to join this channel. We need to grow this channel so that I am able to post new videos in the channel. Let's find a formula for conditional probability. I just told you P by A, PB by A, that is probability of B when A has already occurred, is given by N A intersection B by N intersection A. Okay? If we divide the numerator and the denominator by ns, that is the number of elements in the sample space. See, by ns and this by ns. What is this? Na intersection b by ns is probability of A intersection b. I'm writing it here. Probability of A intersection b, that is probability of A and b, by probability of A. This is probability of A. From here, what do we get? We get P is A intersection B. Probability of A intersection B, that is probability of A and B, is given by PA into P of B when A has already occurred. So when the events are dependent, when the compound events are dependent, probability of AB, that is A and B, is equal to P of A into P of B by A, that is probability of A into probability of B when A has already occurred. Here in this equation, we can rewrite this equation as P of A by B. What it will be? From here, it will be P of A intersection B by P of B. Therefore, this is also equal to probability of B probability of A when B has already occurred. So these two are equal. If we have these values, we can find AB. If we have these values, we can find AB. So this is PAB. We also write this as PAB. And this means P, A and B. That is, the elements are present in both A and B. The elements that are common to these. Okay? This is conditional probability. These two are compound events. So we have conditional probability if A and B were independent. If A and B were independent, this P of A when B has occurred will be equal to PA. Why? Because A and B are independent. It doesn't matter anything for B. PA of B will be PA only. Similarly, PB by A will be PB only. Therefore, when we are studying probability for independent events, we had seen PA intersection B was PA into PB simply. Okay, I just told you that A intersection B, P of A intersection B is also written as PAB, or if there are three elements, then PABC, like this. So you should keep this in mind because we will be using it in our next topic. That is general rule for conditional probability. We just saw conditional probability for two events. Now if we have multiple events, n number of events, then probability of P, A1, A2, to AN, this will be equal to P of A1 into probability of A2 when A1 has already occurred. Next, P of A3 when A2 and A1 both have occurred. Okay, and so on up to the point where we will have P of AN where AN minus 1, AN minus 2 and so on to A1 has already occurred. So this is the general rule for conditional probability. If we will have more than 2, 3, 4 events, we will be using this formula. Clear? Our first question, this is a very good question. It says, if we throw a die and we throw the die again, then prove that probability of getting a 3 in the first throw and 6 in the second throw, these two events are independent. We have to prove this. Let's see how we will prove it. Sample space is 1, 1, 1, 2, 1, 2, 36. So we will have ns equal to 36 when the die is thrown twice. What will be A? The event of getting a 3 in the first throw only, so that will be 3, 1, 3, 2, 3, 3, 3, 4, 3, 5 and 3, 6. So this is A, probability of getting 3 in the first time. So this is the set that corresponds to that. And probability of getting 6 in the second throw. What it will be? 1, 6. That is, we have 1 in the first throw and 6 in the second throw. 2 and 6, 3 and 6, 4 and 6, 5 and 6 and 6 and 6. So these are two events. Now what we do, if they are independent, let's say they are independent. Let's say they are independent. Then what will be the probability of the event that we get 3 in the first throw and 6 in the second throw? This will be equal to 1 by 6 into 1 by 6, because PA is equal to NS. NA is 6, NS is 36. So this is 1 by 6, this is 1 by 6. So this will be 1 by 36. Okay. Let's say this is a compound event. Then the probability will be, we have formula PA intersection B is equal to PA into PB by A. So let's see what is PA intersection B. We have, this is A, this is B. What is A intersection B? Let's see it here. A intersection B. How many elements are there in A intersection B? See, do you find any intersection? 1, 6, 2, 6, 3, 6. See, this and this. So there are only one element. There is only one element. 3, 6 in A intersection B. So P of A intersection B will be 1 by 36, because P of A intersection B will be 1 by the sample space, that is 36. Now in this formula we have 1 by 36 equal to PA, that is 1 by 6 into PB by A, that is probability of occurring a 6, 1, 3 has already occurred there, which is equal to PB by A is equal to now 1 by 6, 6, 6 cancels. But we have PB equal to 1 by 6. If they were independent events, PB was 1 by 6. So here also we are getting 1 by 6. Therefore, this is P. From here we see that PB by A is equal to PB. What is the meaning? The meaning is that A and B are independent events. So we have proved it. Now the second question. For second question also I am taking two independent events. Why? So that you, when I will start taking compound events, you will be able to differentiate between the independent and dependent events. Let's see. The second question says we throw a die and we throw the die again. When we are throwing die once and when we are throwing die the second time, we know that the two events are independent of each other. They do not have any dependency. That if in the first throw we have got 6, then necessarily we will get 6 in the second throw also. These two are completely independent events. So the question says a die is thrown 2 times. What is the probability of getting a 6 in the first attempt, that is the first throw, and an odd number in the second throw? So probability, let's say the first event is A, probability of getting a 6, so that is 1 by 6, we know this. And second event is B, probability of getting an odd number. What are odd numbers? 1, 3 and 5. So 3 by 6, 1 by 2. Therefore, probability of getting a 6 in the first throw and probability of getting an odd number in the second throw, the combined probability A and B will be equal to 1 by 6 plus 1 by 2, that is 1 by 12. So this is an example of independent event. Now I'll take events that are dependent. This is on dependent events. It says in a class 30% of students fail in English. And 20% of students fail in Hindi. And there are 10% of students who fail in both E and H, English and Hindi. So if this is set A, this is set B, then this is set A intersection B. The question is, what is the probability that a student has failed in English when he has failed in Hindi? That is, the student has already failed in Hindi. So what is the probability that he has also failed in English? So what we have to find, if this is B, then we have to find PA by B. That is probability of failing in English when he has already failed in Hindi. This is a compound event. This is a compound event. One event is dependent on the other. Let's say, don't say. From here we get that probability of A is 30%, that is 3 by 10. Probability B is 20%, 2 by 10, and probability A intersection B is 1 by 10. Now we know that probability of A intersection B is given by probability of B into probability A by B. We have to find this. Therefore, probability of a child or a student to fail in English when he has already failed in Hindi is given by PA by B, that is 1 by 10, by PB. What is PB? 2 by 10. So the answer is 1 by 2. There is a 50% chance that if he has failed in Hindi, he has also failed in English. Our fourth example is, understand this question properly. It says there are 2 bags, X and Y, and inside X we have 3 white balls and 2 black balls, and we have the second bag Y which has 2 white and 4 black balls. Let's see. This is X. It has 3 white and 2 black balls. And this is Y, bag Y. It has 2 white and 4 black balls. The question is, what is the probability that whichever bag and balls we select, we get a white ball? That is, it's immaterial that we get this or this. Listen to the language what I am saying. It is immaterial that we get X or Y. So this is this or this. That is probability of getting a white ball when X is selected, and or probability of getting white when Y is selected. Therefore, what is the probability of getting X or getting Y? Half. There are 2 bags only, so the probability of picking X is 1 by 2 and probability of picking Y is 1 by 2. When we pick this ball, the probability of picking X was 1 by 2 and picking white ball from this is 3 plus 2 5, that is 3 by 5. Here probability of picking Y is half and picking white is 2 by 4 to 6. So the probability of A union B, if the first is picking this is A and picking that is B, then P A union B will be this plus this. This is equal to what? 3 by 10 plus 1 by 6. This we can write as, the probability is 7 by 15. Okay.